Okay, we're still going to start off with our same basic principle. I'm using the circuit construction kit, the DC lab from HVAC Education or HVACR.education simulators. Okay, these simulators are put out by Colorado University. We thank them greatly for doing this. And this is just a visual representation. I want to talk a little bit about parallel circuits. Okay, so I have my base circuit, what I've drug and dropped different components around. And in this case, we're going to go ahead and I'm going to use some light bulbs just to simulate the different circuits. Okay, and let's go ahead and I'm going to choose that light bulb there. Okay, I'm going to use another wire. Okay, and it's not going to let me do that there, so we'll just shorten that one up there a little bit. You can only connect these wires together where you have the connection points. Okay, I'm going to come down here. I'm going to throw another light bulb in here. I'm going to put another wire here. I like having series circuit or parallel circuits drawn out in simulators just like I would have drawn them out here. You notice I have an amp meter there. I am actually going to put another, I'm going to break that connection and I'm going to put another amp meter in there as well. Okay, and you know what? We may break that connection there, and I'm going to put another, just because I want to show you a few things on parallel circuits. So we're going to put another amp meter in right there. Okay, let me make these connections back. Okay, straighten this out a little bit. I know I'm picky about some of this stuff, but you get that way after a while. Okay, so I have a parallel circuit here with two bulbs. Right now, nothing's powered, so I have 0 amps. Let me check on the battery voltage. I have this set for 60 volts. It's half of our 120 that we normally use, but that's fine. Now, this is a DC circuit, okay? It's much easier to show you this with a DC circuit just because of the way the current moves in this, okay? It moves in one direction, so I can show you electron flow. So right now, if I come down here and take my voltage across that switch, again, voltage across any device is just putting your meter across the device. I have 60 volts. Why is that? Because voltage across an open switch is always source voltage. Okay, if I change this voltage to 120 volts, I get 120 volts. But voltage across an open switch is source. Voltage across a closed switch, notice I turned the switch on, which means it's closed. We now have 0 volts. Again, open switch, source voltage. Please believe me. Closed switch, 0 voltage. All has to do with that there's a difference in potential. Now, if I take my voltage across this first load, I have 60 volts. Okay, if I go from each side of the load, I have 60 volts. If I go to the bottom load, I have also 60 volts. Now, this is a big difference from the series and parallel circuit we just talked about. Okay, seriously, this is a big difference between the series and parallel circuits we just talked about. Okay, I have the same voltage on each load. So loads in parallel all get source voltage. Okay, notice I have current of 0.06 amps here, current of 0.06 amps here, adding up to 0.12 amps. Let's go ahead and change the resistance of this bulb a little bit. I'm going to lower this way down. Notice I take it down to 100 ohms. My amperage goes up in this leg. Total current goes up, but this leg stays the same. So if I come down here, okay, and lower the amperage there all the way down to my 100 ohms, I now have equal amperage again, but my total current is the sum of both currents. So in a parallel circuit, all loads get source, and all loads, the total branch currents add up to the total current. Okay, now, let's open this. Okay, does it change anything having to do with my series circuit laws? Not really. Okay, if I have, let's throw another bulb in here. Okay. Probably should have used the lower resistance bulbs that I had earlier. But let's throw another bulb in here. I have 0 amps, 0 amps, 0 amps. Switch is open. Okay, now, this circuit now, instead of my 0.60, okay, has 0.05. Again, we have our now, the top leg, okay, is using 2 bulbs. So both bulbs are splitting that current. Bottom leg only has 1 bulb. Okay, so if I take my voltage reading across the first load there, 30 volts. Okay, if I take my voltage reading across the second load, okay, and I'm going to do the same thing, 30 volts. Now again, if I change my resistance of that second load, okay, I can start using more of the voltage to the point where there's no resistance or no voltage available for that first load. So again, now this is a series parallel circuit. You do your series circuit first, and then you calculate all the values for your parallel circuit. And if I wanted to, I can open my switch here. Let's open the switch. Let's throw some wiring in. And I can do the same thing that I did with my other circuit. Is okay, I can create a bypass. So I can come down here. I can grab another wire. Okay, and I close this switch. Okay, and I can bypass that second load. So all of a sudden, we have that load. See what happens when I put that other load in series with it? Okay, but no matter what, each one of my paths, each one of my rungs in the ladder will add up to the total current. Okay, so that is just a brief description of parallel circuits. Parallel circuits are the workhorse in the HVAC industry. And again, you can access all of these simulators your own at hvacr.education. There's a ton of them out there, a lot of them good, okay, and they're all available. The HTML5 simulators, okay, you can get to, these are all HTML5 coded. Java simulators are there as well. Okay, there's a ton more of Java simulators. Okay, you have an AC construction as well. Now, Java simulators use, they're a little bit slower loading, and you may see a little bit of lag on them. Okay, because it actually does load Java in the back end on the server, and it creates a virtualized environment. So the loading time of that is a little bit slower. And we just have to give it the chance to load. You see, it takes a little bit to load that Java program. Okay, and there you have your agreement. We're going to just accept and continue. Okay, and then you can do the same thing we were doing here. Okay, I can grab my source. Okay, we'll do an AC source. I'll grab my wire. Okay. And I can do the same identical thing I was doing in the other one. Now this one's important because the your AC source, okay, when we start wiring this, and I'm just going to show lifelike, okay, I can put my switch in. Okay, as long as you get your connections in there right. Again, with Java, with the Java simulators, it just does take a little bit longer. Okay, so try to use the HTML5 ones when you can. Okay, if you can't, fall back to the Java ones. Just realize it takes a little bit longer on the Java. Okay, so hopefully you got something out of this. Parallel circuits, voltages, all sources get, or all loads get full source voltage as long as there's nothing in series with it. Okay, all rungs of current add up to the total current. And voltage across an open switch, as with any circuit, is full source. Voltage across a closed switch is 0. And current will always take the path of least resistance.